So me too, and I said me too. I be affected the boosting, and I said.
Yeah.
Supposed to. You brought it. I'll take it. Hello. 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 Try two. Try two. Try two. Try two. Try two. Hello. Testing.
GSTS. I wish us you the best in the second contest. The contest comes to you in 4 rounds. The first round have simple and direct questions, and I'm expecting simple and direct answers from you. If you are successful with your major question, the bonus will be passed on to the two. If you are answering the bonus correctly, within a one month, so you lose a by ringing your bell. If you want to be your best round.
Prolactin, and its function is
Again,
prolactin, and its function is to stimulate the production of milk in mammals.
I'll take that. Next set, and I have a preamble. Preamble to all schools. In a redox titration experiment, a student determines the concentration of an iron 2 sulfate, FeSO4, solution by titrating it against a standard solution of acidified potassium manganate 7, acidified potassium manganate 7, KMNO4. The endpoint is detected when the solution turns permanently pale pink due to the first excess of MnO4 minus. In a redox titration experiment, a student determines the concentration of iron 2 sulfate, FeSO4 solution by titrating it against a standard solution of acidified potassium manganate 7, KMNO4. The endpoint is detected when the solution turns permanently pale pink due to the first excess of MnO4 minus. That's the preamble. St. Peter's. A student pipettes 25.0 centimeter cubed of the iron 2 sulfate solution into a conical flask, adds dilute sulfuric acid, and titrates with 0.0200 mole per decimeter cubed KMNO4. The titer value is 20.0 centimeter cubed. Calculate the concentration of Fe2 plus ions in mole per decimeter cubed. Yes, come.
0.0800 mole per decimeter cube.
That's correct. With the same preamble, Opokuwari School, a student titrates 25.0 centimeter cubed iron 2 solution with 0.0100 mole per decimeter cube KMnO4. The average titer is 30.0 centimeter cubed. Calculate the mass of iron in milligrams present in the 25.0 centimeter cubed sample. Take the atomic mass of iron to be 56.0 grams per mole. Yes, come.
Six point 72 by 10 raised to an exponent of 2 milligrams.
That's incorrect for a bonus. All right. The right answer is 84.0 milligrams. GSTS. In one titration, 25.0 centimeter cubed of Fe2 plus solution is titrated with 0.0400 mole per decimeter cubed KMnO4. The titer volume is 12.0 centimeter cubed. However, the student forgot to add dilute H2SO4 before titration, and the reaction was incomplete. After adding acid and retitrating, the new titer is 20.0 centimeter cubed. Calculate the percentage error from the first attempt. Let's come.
Error is 8.16%.
That's incorrect for a bonus. The right answer is 40.0%. Next set and have a preamble for all schools. Preamble. Take Planck's constant to be 6.60 times 10 to the power negative 34 joule second, and speed of light 3.00 times 10 to the power 8 meters per second. St. Peter's. A certain metal requires a photon energy of 1.80 electrovolts to just eject an electron. When light of wavelength 6 is used, electrons have kind 0.270 electrovolts. Calculate the photon energy in electrovolts. Yes, come.
2.07 electron volts.
That's incorrect for a bonus. All right, Opokuwari School, with the same preamble. The threshold energy for a metal is 2.00 electrovolts, When light of wavelength 450.0 nanometers strikes the surface, the emitted electrons have kinetic energy 0.760 electrovolts. Determine the photon energy in electrovolts. Yes, come.
1.2. Yeah, the decimal place. 1.239 electron volts.
That's incorrect for a bonus. GSTS with the same preamble. A photocathode has a work function of 1.90 electrovolts, illuminating with light of wavelength 500.0 nanometers, produces electrons with kinetic energy 0.580 electrovolts. Calculate the photon energy in electrovolts. Yes, come.
The energy is 2.48 electron volts.
Into the microphone, louder again.
The energy is 2.48 electron volts.
Yes, you are right. So St. Peter's, you were so close. 2.06 electrovolts. Then Opokuwari, 2.75 electrovolts. Next set. Next set, St. Peter's. Given f of x equals x plus 1 all over the expression x minus 2, and g of x equals 4 all over the expression x plus 3. Find g of f of x. Yes, come.
A fraction with a numerator of 4x minus 8 and denominator 4x minus 5.
Yes, you're right. Opokuwari, given f of x equals 2 all over the expression x minus 4, and g of x equals the expression 3x all over x plus 1. Find g of f of x. Yes, talk.
6 over x minus 2.
You're right. GSTS. Given f of x equals the expression x all over x plus 5, and g of x equals the expression x minus 1 all over 2x. Find g of f of x. Yes, come.
-5/2x.
You're right. Next set, I have a preamble for all of you. Preamble. Assuming all compounds exist, calculate the empirical formula of the following compounds given the mass of each element present in the sample. Assuming all compounds exist, calculate the empirical formula of the following compounds given the mass of each element present in the sample. St. Peter's. A 10.0 grams sample of a compound contains 3.0 grams carbon, 0.5 grams hydrogen, 2.0 grams nitrogen, and 4.5 grams oxygen. Yes, come.
C5 H
That's incorrect.
O
Bonus.
C2 H3 NO2.
That's incorrect. Ukura, your major question. With the same preamble. A 4.0 gram sample of a compound contains 1.8 grams carbon, 0.3 grams hydrogen, 0.7 grams nitrogen, and 1.2 grams oxygen. Yes, come.
C C6 H12 N2 O3.
You're right. Yeah. Sample of compound contains 4.8 grams carbon, 0.5 grams hydrogen, 1.4 grams nitrogen, and 2.4 grams oxygen. Yes, come.
So we have C, D, H,
Please, louder.
C, 8, H, 8, 10, N, 2, O, 3, O, 3,
Everything again.
C, H, C, 8, H, 10, N, 2, O, 3.
Yes, you are right. Next set, St. Peter's. A uniform meter stick of mass, 120.0 grams, has a 50.0 grams mass at the 20.0 centimeter mark and an 80.0 grams mass at the 70.0 centimeter mark. Find the pivot position for equilibrium. Yes, speak if you have an answer. Speak.
The equilibrium point is 50.8 centimeters.
That's incorrect. For a bonus. OWASS. A uniform meter stick balances at the 55.0 centimeter mark when a 30.0 grams mass is at the 10.0 centimeter mark and a 70.0 grams mass is at the 80.0 centimeter mark. Find the mass of the meter stick. For a bonus. GSTS. A uniform meter stick of mass 100.0 grams balances at the 45.0 centimeter mark when a 40.0 gram mass is at the 20.0 centimeter mark and an unknown mass M is at the 80.0 centimeter mark. Find M. Yes, come.
Four T 6.3 grams.
That's incorrect. For a bonus. So, St. Peter's, your answer was 50.4 centimeters. Opokuwari, 80.0 grams. And GSTS, 14.3 grams. Next set of questions, and I have preamble for all schools. Preamble. Find the interior angles in degrees for a convex quadrilateral if the exterior angles are in a given ratio. Find the interior angles in degrees for a convex quadrilateral if the exterior angles are in a given ratio. St. Peter's, 1:2:3:4. Yes, come.
The, the interior angles are 144 degrees, 108 degrees, 72 degrees, and 36 degrees.
Yes, you're right. Opokuwari with the same preamble. 1:1:2:2. Yes.
120 degrees, 120 degrees, 60 degrees, and 60 degrees.
That's incorrect for a bonus. GSTS. 2:3:4:6. Yes, come.
Okay, so we have one to be 132 degrees. The other one is 108 degrees. The other one, the other one is 84 degrees. And the other one is 36 degrees.
Yes, you're right. So I have here, OWASS, Opoku School. I have 135 degrees, 135 degrees, 90 degrees, and 90 degrees. That's what I have here. Next one, St. Peter's. A chemoheterotroph and a photoautotrophs are placed in separate sealed transparent chambers containing only inorganic nutrients and light. After 1 week, which organism survives and why? Yes, come.
The photoautotroph survives, and this is due to the fact that it uses the inorganic materials present in light to synthesize organic food for use, whereas the chemoautotroph does not utilize light to, to synthesize organic materials for use.
I'll give you one. And I'll give you the reason later. Opoku, explain why all animals are chemoheterotrophs, but not all chemoheterotrophs are animals.
All chemo all animals are chemoautotrophs, and this is because they can utilize like chemical chemical reactions to like produce their own food. But
Please,
not all,
I can't hear you. Louder, speak louder into the microphone.
all animals are chemoautotrophs, and this is because they are able to like use chemical reactions to synthesize needed organic molecules, whereas not all chemoautotrophs are animals, and this is because some chemoautotrophs, bac- such as a bacteria, does not fall into the class of animals since they are protists.
I'll give you one. GSTS. A farmer adds organic compost to soil. Explain how chemoheterotrophic bacteria in the soil benefit from this, and how this indirectly benefits a photoautotroph or photoautotrophic crop plants.
So the chemo the chemoheterotrophic bacteria oxidize the organic organic compost and break it down to release all the components of the organic compost and energy. And the photoautotroph need simple inorganic substances from this organic compost and other minerals for them to be able to produce organic food materials for survival. And the bacteria uses the energy to survive because it needs the organic compost to in order to survive. That is
I'll give you two out of three. Okay, St. Peter's. You're able to tell me that the photo autotroph survived. That was true. But the explanation you were giving, you actually interchanged it. So this because it can synthesize organic compounds from carbon dioxide using light energy. Even without organic food, the autotroph dies because it requires performed and then preformed organic compounds for energy and carbon, which are absent. And that is why I gave you one. Opokuwari. Chemoautotrophs obtain both energy and carbon from organic compounds. Animals ingest food and internally digest it, fitting this definition. However, fungi, many bacteria, and some protists are also chemoautotrophs, but are not animals. They absorb nutrients externally or decomposed matter. Then GSTS. You're actually saying it though, but some key points I was expecting or I was looking for was missing. And that is how come I gave you two. Chemoheterotrophic bacteria decompose the organic compost, obtaining energy and carbon while releasing inorganic nutrients into the soil. The photoautotrophic crop plants that absorb these nutrients uses light energy to synthesize organic compounds, benefiting from this bacterial decomposition. So actually, you were explaining, but I actually didn't see the part that you are talking about, utilizing the organic and then inorganic compounds. I didn't actually see that, so I gave you 2 out of 3. On that note, we've come to the end of the first round. Okay, so there was a protest from Opokuwari School in St. Peter's for the physics sets and the mathematics. So Opokuwari was actually protesting for the mathematics question that I gave. So the question reads, find the interior angles in degrees for a complex quadrilateral if the exterior angles are in the given ratio. And so they gave the answer to be 120, 120, 60, and 60. It's actually the correct answer. So give them the 3 points. It was their major question. Then St. Peter's. For the physics sets, they were asked to find they were asked to find the photon energy in electrovolts given Planck's constants and then the speed of light. And then they were given the photon energies. So the answer I have here is 2.06. Actually, when you put into the formula, it should be 2.07 as they gave. So they gave the answer 2.07. So give it to them for that one. 0.27 rather. 0.27 rather. So they are actually correct. So effect that change. They were also protesting on the biology set that was given. And as for that one, the 1 point I gave is fair. So at the end of the first round, hello. At the end of the first round, here are the scores. The people are school, 12 points. St. Peter's Senior High School, 16 points. Ghana Secondary Technical School, 17 points. Hello? Round 2. Please, with this round, I'll be reading some questions for you, and you are to alert me with your bell. The moment you ring the bell, whichever place I've reached, I have to stop for you to answer. So once you ring your bell, your answer should be ready. I will not wait for you to be telling me we have and so forth and so on. Just ring and give me the answer. If you delay the 3 seconds, after 3 seconds, I will nullify it and pass on to any other school who is ready. Or precisely, you get minus points for that particular question. All right. Let's try our bell. St. Peter's. Ukwari. GSTS. All right. First one. Find the sum of the integral roots of x cubed minus 9x squared plus 26x minus. All right. GSTS. You are right. Next one. Under the linear transformation, t x comma y equals x plus y comma 2x minus y. The image of p is Oh, 4, GSTS, come. That's incorrect. Q, 4, 1. Yes, come, OWASS.
5 over 3, comma 7 over 3.
You're right. For 2 points. Next one. An equilateral triangle and a square have the same perimeter if the triangle has area 36 √3 centimeter square. Find the area of the square. Yes, GSTS, come into the microphone.
144 centimeters square.
That's incorrect. All right. The right answer is 81 centimeter square. Next one. A gas has initial pressure P, volume V, and temperature T. Its volume is reduced to V over 2, and its temperature is increased to 2.8 T. Find the new pressure. GSTS. GSTS.
5.6 P.
You're right. Next one. A civil engineering lab test. A civil engineering lab test a sample of quicklime, CaO, used in mortar production. A 15.0 gram portion of the impure quicklime is slaked with excess water. After complete reaction, the resulting calcium hydroxide, CaOH2, is dried and found to weigh 11.0 grams. Calculate the percentage purity of the original quicklime sample. %55.5%. Next one. What is the hybridization of oxygen in sodium borate? Come, GSTS.
So we have SP3
You're right. Next one. An environmental lab analyzes a soil sample containing 6.70 times 10 to the power 15 atoms of the radioactive contaminants. The sample's activity is found to be 8.00 times 10 to the power 3 becquerel. Determine the decay constant of the contaminant. GSTS.
6.00 by 10 raised to an exponent of -3 per second.
Incorrect. (1.19 times 10 to the power -12 per second). Next one. In a hospital MRL magnets, the inductor has inductance of 0.8 Henry and reaches a steady current of 5 amperes. GSTS.
10 joules.
I continue. Calculate the magnetic energy. St. Peter's.
1.0 by 10 raised to an exponent of 1 joule.
Incorrect. Calculate the magnetic energy stored and state by what factor the energy increased if the current is doubled. Yes, Opokuwari.
Energy is 1.0 by 10 exponent 1 joule, and it increases by a factor of 2.
That's incorrect. Okay, so 10 joules and increase by a factor of 4. Next one. The Artemis lunar landed must achieve escape velocity from the moon to return astronauts to the Orion capsule in the lunar orbit. Given the moon radius r subscript m equals 1.60 times 10 to the power 6 meters, and surface gravity, that is J subscript m, equals 1.0 meters per second square, calculate the escape velocity from the moon's surface. Yes, St. Peter's.
1.8 by 10 raised to an exponent of 3 meters per second.
Yes, that's correct. Next set, or next one. How does vivipary affect seed dormancy? Opokuwari.
Vivipary affects seed dormancy, and this is because in vivipary the seeds are able to develop from the parent plant and obtain nutrients from the parent plant, and hence with seed dormancy the viviparity is able to break the seed dormancy and cause the plant to grow by ignoring the seed dormancy.
I'm not accepting that. So viviparous seeds amount of oxygen still bound to hemoglobin in venous blood. Venous oxygen reserve, or you can also say oxygen reserve or residual oxygen bound to hemoglobin. Next one. And that's the last question for round 2. During the Artemis mission, astronauts spent several days in microgravity while traveling to the moon and then experience 1/6 X gravity on the lunar surface. Explain why prolonged exposure to reduced gravity leads to loss of bone density. Opokuwari.
Exposure to reduced gravity leads to loss of bone density, and this is because in the reduced gravity there is not much like activities for the bones, and hence the bone is not able to undergo compaction, hence it becomes less denser than it was in the higher gravity.
You want to say again?
like microgravity reduces bone density, and this is because in microgravity the bone is not able to undergo the usual work that it would have done in the greater gravity, and this causes the bone to lose its density.
Okay, let me listen to St. Peter's.
Prolonged exposure to gravity, microgravity that is, leads to muscular atrophy, that is, the wasting of muscles, since the effect of gravity is not that much felt on their bones and the muscles. The muscle will the muscles are going to lose their weight, and the bones are not going to be able to support the muscles that are present on them, hence leading to the wasting of the muscles.
I'm not accepting both answers. So, bone is a dynamic tissue that constantly remodels. Osteoblast builds bone, osteoclasts breaks it down. On Earth, mechanical loading from gravity stimulates osteoblast activity. In reduced gravity, that is microgravity or lunar gravity, mechanical loading decreases. So osteoclast activity dominates, leading to net bone loss, which is density decreases. So was you two, but for this one, I can't accept round two. Protests. Speed-based question that reads, how does viviparity or vivipary affect seed dormancy? So they were able to explain. They left one thing out, which was the unsuitable for storage. But upon consultation, that's the key thing is that they lack seed dormancy and making them germinate immediately. So I'm accepting I'm accepting that one. But for the other one, not all key terms were actually mentioned. So I'm not accepting that one. For the biological explanation regarding bone density, for that one, you are not getting it. So thank you. At the end of the second round, here are the scores. Boko High School, 15 points. St. Peter's Senior High School, 17 points. Ghana Senior High Technical School, 22 points. True or false? Round 3. So I'll be reading some statements. You have to alert me whether the statement I give you is true or false. I'll be starting with you, St. Peter's, go to OWASS, and then finish with GSTS. St. Peter's, high batutes are involved in exudation of liquid water, that is guttation, and play no role in solution. OWASS. Root hairs are the main organs for water and mineral absorption, but do not actively regulate osmotic balance. To the microphone. Yes, you are right. Please keep your microphone on. Keep it on. You only regulate it this way, or else it will always give you problems. GSTS. The Casparian stress in the endodermis forces water and solids to pass through the symplast, allowing selective reabsorption of ions. Yes, you're right. Next one, St. Peter's. Argon with atomic number 18, mass number 40, and calcium with atomic number 20 and mass number 40 are isotopes.
False.
You're right. Opokuwa is school. All isobars are also isotopes. You're right. Yes. The pair Na with atomic number 11, mass number 23, and Mg with atomic number 12, mass number 24 are neither isobars nor isotopes.
False.
That's incorrect. It's a true statement. St. Peter's. The absorption line from n is equal to 1 to n is equal to infinity has the shortest wavelength in the Lyman series. Yes, you're right. Who are in school? All absorption lines in the Balmer series originate from n is equal to 2. Yes. The wavelength of n is equal to 1. 2 n is equal to absorption line in hydrogen is longer than line. Yes, right. St. Peter's. Rhodopsin is the photopigment found in rod cells and is bleached by light.
False.
That's incorrect. The true statement. Opokuware. In the dark, photoreceptor cells are depolarized and release neurotransmitters glutamate. Yes, incorrect. That's the true statement. Yes. Macular degeneration affects only rod cells, not cones.
False.
Yes, you're right. St. Peter's. The diagonal relationship is strongest between elements of group 1 and group 3.
True.
That's incorrect. It's a false statement. Opokuware. Boron. Yes, you're right. GSTS. Regional relationship occurs due to similar ionic sizes and charge densities.
True.
Yes. St. Peter's. Centripetal acceleration is given by A subscript C equals omega squared R and is directed tangentially.
False.
Yes. Pokuware. For a given angular velocity, points closer to the center have Yes, you're right. GSTS. If the radius of a circle doubles, while angular velocity remains constant, linear speed doubles. Yes, come. Yes, you're right. All right, on that correct answer, we've come to the end of the third round. All right, let's finish with the last two sets. St. Peter's. The logarithmic function log ax is defined for all real values of x. Yes, you're right. Opokuware. Log a1 is equal to 0 for any valid base a.
False.
Let me take it again. Log base A of 1 equals 0 for any valid base A. Base A. True. You're right. Last set. St. Peter's. A matrix with determinant 0 has no inverse. True. You're right. Pokuware. Matrix multiplication. Hello? Matrix multiplication is always commutative.
False.
Yes, you're right. GSTS. The identity matrix leaves any matrix unchanged under multiplication.
True.
Yes, you're right. End of round 3.